Fastest accelerations. Intermittent acceleration in space. Tsiolkovsky brought a man into space, and intermittent acceleration will get lucky and bring the man back to Mars and other planets of the solar system. To fly to other planets of the solar system, you need high cosmic velocities, about 100 kilometers per second, 200 kilometers per second, 300 kilometers per second, and more. Modern jet engines cannot provide such high cosmic velocities. According to its physics, they have reached their limit. I found another solution to this problem: intermittent acceleration. In space and vacuum and weightlessness. If a rocket flies at a constant speed, then it can be considered as being at rest. This means that any jet thrust can give such a rocket acceleration regardless of speed, rockets, and regardless of the emission of gas from the jet engine nozzle. For example, in space, a rocket has a constant speed of 20 km/s. The jet engine has a speed of gases leaving the nozzle of 4 km/s. The jet engine turns on and accelerates the rocket by 4 km per second and turns off. Now, the rocket has a constant speed of 20 km per second plus 4 km/s equals 24 km/s. The jet engine turns on again and once again accelerates the rocket plus by 4 km per second and turns off. The rocket already has a constant speed of 28 km per second. Thus, by turning the jet engine on and off, you can achieve greater cosmic speeds, 100 km per second or more. Intermittent acceleration in space is an axiom. No other proof is required. Intermittent acceleration in space is a method invention. Constant acceleration in space. In space, in vacuum and weightlessness, there is only one resistance to movement: inertia. Rest of the mass if we neglect the forces of gravity. Under these conditions, acceleration depends on the duration of the jet thrust. The longer jet thrust, the greater the acceleration. For example, jet engine in 4 minutes. Work will do 2 times more acceleration than in 2 minutes. Work. Intermittent acceleration is actually proof that constant acceleration in space will work correctly, as it should. Constant acceleration in space is a discovery in space physics, not an invention. Physics of space, somewhat different than Earth physics. This requires experimental verification in orbit, ISS, so that there is no unnecessary controversy on this topic. Fastest jet engine in space. One option. An explosion is the complete combustion of the entire volume of a substance down to the last molecule in an instant. This means that the explosion can provide the fastest jet thrust of sufficient power for achieving high cosmic velocities. An explosive of equal weight gives more energy than rocket fuel. A jet engine powered by explosives has a cylindrical shape. The cylinder has a valve on the axis. The damper rotates 180 degrees on its axis, back and forth. The explosive, in the form of a thin sheet, sticks to the valve like a sheet of paper. Such explosives explode and give a push jet thrust. Then the damper turns back and the explosive sticks again like a piece of paper. Damper turns back, an explosion occurs again. This gives jet thrust. The jet engine runs intermittently. In space, this is how a jet works. The engine will do. Option 2. The explosive jet engine is cylindrical in shape. Explosive sheets, separated by a gasket. This gasket prevents detonation from the first explosion. Each sheet of explosive has its own contact for explosion. These explosive sheets work only when the signal arrives one by one. Option 3. A jet engine has a cylindrical shape, a combustion chamber, and a nozzle. The explosives enter the combustion chamber in portions. Such an engine gives intermittent jet thrust. In space conditions, a jet engine powered by explosives will be the most economical, suitable. Email Toller88@mail.ru. Mikhail Timofeev, Amga, Yakutsk. Clerk, Gogoleva OA.